Hello, welcome to the Dr. Gill Show. My guest today is Gary Taubes. Welcome to the show, Gary.
Hi, Gil. Thanks for having me.
What a pleasure it is to see you, Gary. I have known Gary for over 20 years now. Gary came out and spoke at our local university about 19 years ago. I'll never forget the talk. I've been following you, Gary, for years and years. And I hope you don't mind if I say you're one of the most important and influential health and science writers and journalists of our time.
Well, thank you. I hope so. Again, the problem is trying to have influence and failing. So at least I'm trying to be one of the most influential science journalists of our time.
Yeah. That's all we can do in life, and it's not getting knocked down, it's how you get up, you know. And I'm getting a little older, Gary, and I know, one of the purposes of life is to make the world a little bit better than when you found it, and be a contributing member, and you certainly have that ethic, and you walk the walk. What I'd like to talk to you about today, Gary, is calories, the obesity epidemic, and why after all this time and having so many smart people looking into the problem, is the problem still there, and if nothing other than that, getting worse? Can we talk about that today?
We can. Small subject matter, easy to handle.
Easy.
Quick,
peasy.
Short answers for everything.
That's right. For every complicated question, there is an easy answer, which is wrong.
Which is wrong, yeah.
Which is wrong. And as you know, Gary, I'm a practicing physician. I'm a reproductive endocrinologist. I'm a fertility specialist, and obesity is a huge contributor to infertility. Everything we have in medicine has a call. Everything. Most diagnoses have a code, has a number and a description, and we use something called the ICD-10 code. And code E66.0 says obesity due to excess calories. There isn't one for obesity. It's obesity due to excess calories. Like, for example, there's a guy in the intensive care unit with a head injury, right? Brain trauma. He's coded brain trauma, not brain trauma due to riding a motorcycle without a helmet. If you follow me, it's the only diagnosis where the assumption is you're obese because you're a sloth, right? Because you eat too much and you're a slob.
Yeah. And actually, I'm surprised that's in there. I mean, you see it everywhere.
Yeah.
This is what's obsessed me, and where you really, it's crazy. I mean, it's from my perspective. I've written, 5-6 books now on nutrition and chronic disease, starting with Good Calories, Bad Calories, which took 5 years, and then the readable version of that, Why We Get Fat, and then Case Against Sugar, and Case for Keto, and my latest, Rethinking Diabetes. And they're all based on this sort of, in order to do this, I did something which every scientist should do whenever they get into a field, is like you go back and you look for the evidence, right? So you've got this certain belief system that you're supposed to accept when you start doing your work. Like when you went to medical school, you were taught more or less what to believe, but you weren't taught the history of why you should believe it. So this idea that obesity is caused by eating too much, which sounds intuitively obvious, has a history. And I made the mistake as the journalist of actually going back and looking for that history, and you find out that it sort of came out of the late 19th century. There was this general idea that obesity is caused by gluttony and sloth. There's this world is full of people like famously Falstaff and Shakespeare who eat tremendous amounts of food and drink tremendous amount of alcohol and are obese. So they would assume in the late 19th century that those people earned their obesity by eating
Ah,
too much. The
that
technical term for them, which was coined by a German named von Norden, was exogenous obesity. But then the world was full of people who got obese without eating any more than lean people did. This was always like, an undeniable observation. It was like your Aunt Ruth or your colleague, Dr. Schmagegi. It was like there was
right.
always somebody you knew who didn't eat any more than you did and yet was obese. Like when we were growing up, the kids in high school, back when there was 2 obese kids in every class rather
Right.
than 30,
Half.
it wasn't that they were gluttons. They were just different. Their bodies did something differently with the food they ate than we did. So we could eat what we wanted, and they blew up like balloons, and we didn't. So it's funny. This idea that obesity was caused by eating too much was eventually rejected by the very best scientists in medicine in the 1920s and 1930s. This was the German, Austrian medical science was 20 years in front of the U.S. I mean, they basically pioneered in any science in the 1920s and 30s. Like the best physicists were Germans and Austrians, the best chemists, the best biochemists, the best biologists.
Histologist.
They won,
Pathologist.
yeah, they won all the Nobel Prizes, and there were these researchers studying obesity too, and they said, look, this idea that we eat too much doesn't make any sense. And if for no other reason than the world is full of people who don't eat a lot of food and become obese anyway. And so they eventually accepted this idea that obesity was like a constitutional problem. You were born with a predisposition to get obese, and that predisposition seemed to be determined by the nervous system and the endocrine hormones. So it was a hormonal issue, and it was a neural issue, neuroendocrine disorder. And it wasn't how much you ate, it was what your body did with what you ate.
Right.
Which is a line I originally got from Eric Westman, but this is exactly how they thought about it 100 years ago. So by the 1930s, they've rejected the idea that obesity is an energy balance disorder, this excess calorie thing. It's like, yeah, if you get bigger, you took in more calories than you expend, but it explains nothing about why some people get fat and others don't.
Right.
And then World War II comes along, and the German and Austrian school evaporates. I mean, literally, first of all, with one exception, all the major researchers happen to have been Jewish.
Yeah,
So by
there you go. Yeah.
by 1933 in Germany, they're done. And by
Right.
1938 in Austria, they're done. And a lot of them emigrate to the U.S., but when they come to the U.S., unlike the physicists who came to the U.S. and got tremendous positions because we had to build atomic bombs, so the Manhattan Project was loaded with brilliant European physicists who were trying to stop Hitler from getting the bomb first.
Right.
In medicine, and we kind of wanted nothing to do with these people. So they tended to get third, fourth-rate jobs wherever they could. And then the war comes, all discussion of obesity shuts down, and after the war, all these young American doctors come back from fighting the war. They justifiably hate the Germans and have zero desire to read the German medical literature.
Right.
And they recreate the science of obesity with the gluttony and sloth thinking. And it's as clear as day in the literature. And in my new book, now I actually have the German literature available as well, and AI programs will translate it for free. It's a wonderful experience to read this stuff. It's also great procrastination because I don't like writing. But
It's a new book. I want to be able to, people can find this. Is it about to come out or it just came out?
No. I'm working on it. Maybe 2-3 more years. It's
Right.
half of my time, and I'm not desperate. If I'm not financially desperate, it's hard for me to dig in and get a book done.
I know. Throughout your young life, you had to write an article to pay the rent, which is quite a motivation.
Yeah. Now, for better or worse, it's not quite that bad. So, anyway, it's the history. So this whole idea that obesity is caused by eating too much is becomes conventional wisdom from the 1960s. It becomes an eating disorder. The 1960s, the field is dominated by psychologists and psychiatrists trying to figure out how to get fat people to eat less. They don't,
Yeah.
all this other science that had been worked out by brilliant scientists, forgotten. It's as though it's, the way I phrased it in one essay I wrote, I said it's as though the science of excess fat accumulation, which is obesity, had nothing to do with the science of fat accumulation itself. Because all you're trying to do is figure out why people eat too much. Because again, we're saying obesity is caused by eating too much. That's what your definition said, with more syllables. And if you're focusing on eating too much, you're not focusing on the sort of physiological systems that regulate fat storage. And that could easily be dysregulated to create excess fat storage, which is obesity.
Yeah. You brought up a great example when you gave your lecture here in Columbia so many years ago. People get burns and they have transplants. And it turns out the buttocks are a good place to harvest tissue from because you don't see the scar, right? And you talk about a guy. Right. Yeah. So if a person has a burn and they harvest some skin from the buttocks, right, and they put on weight, that graft gets fat and the rest of the arm doesn't.
Well,
right?
That's what, actually, I was just going to see, that it wasn't a graft from the buttocks, it was a graft from the abdomen. So so the way when these Germans and Austrians were trying to figure out obesity, and this process begins in 1909, more or less, and then goes through the 1910s. Everything breaks for World War I in Europe, and then the flu epidemic. So you get very little done between 1915 and 1920, and then from 1920 to 1930, they're looking at the literature, and they're basically looking at all these sort of bizarre cases of fat accumulation and how people accumulate fat differently. And when you go back to these textbooks and the monographs they wrote, they're full of photos of different types of obesity and different people with obesity and where they're fat. And
it's a great series of pictures. It's amazing what you show, what you have found.
And this one case turned out to be two cases now that I have all the literature. There's a young girl who has a burn on the back of her hand, and so they take the graft of skin from the abdomen, and she grows up, and as she grows up, she becomes obese, and one of her hands is completely normal, and the hand with the skin graft on the back has this huge puff of skin. And I'm wondering if I have I found, again, in the past year, the internet has changed research, obviously, dramatically. So not only, now I could find virtually anything. And either it's online and downloadable, or you can find a bookstore where you could buy the long thrown out volume of whatever obscure journal it was published in. And somewhere in here I have the photo from the original article. And unfortunately, I'm not going to be able to pull it up. And if I do pull it up, I don't know if I'll be able to share it with your readers. But it is surreal. Grotesque. There's nothing subtle. It's like, here's her hand, and there's this, boom, square of skin that's clearly accumulated massive amounts of fat.
From hormones, not from calories.
Well, and their point is... clearly there's something about the tissue itself that determines whether or not it accumulates fat. And it's so specific to the tissue that if you move the tissue to elsewhere in the body, it takes its ability to store fat with it. And this is why, we all store fat, like they point, we don't store fat in the forehead. We don't store fat on the back of our hands. We do store it here, and we store it here on our love handles. And some people are, there are these cases called progressive lipodystrophy, where they're emaciated above the waist. and
Right.
obese below the waist. And by emaciated, they would take biopsies, skin biopsies, and you could not find any fat cells at all above the waist, even in some classic deposits, something called Bichet's tissue, which is in the chin somewhere. It's babies
Uh-huh.
develop it to help them suck on,
Yeah.
get their milk
Yeah.
when they're
Yeah.
suck. And there's always fat in that deposit, but in these usually women, nothing. It's like the fat above the waist has vanished and the fat below the waist has accumulated to excess. And in order to explain this, you have to start postulating the nervous system's involved, because if it's just hormonal, it's going to be everywhere.
Global.
Or,
Yeah. Yeah.
but if it's half the body, they had cases where somebody would break their spine and then become obese below the waist. So this signaled that the central nervous system was doing something to determine fat storage. And so they do experiments with frogs where they'd either sever their spine or they'd sever the nerves going to one leg but not the other. And the leg that had the nerves attached would not get fat, and the legs where they severed the nerves would accumulate excess fat. And so the assumption was that the nerve cells are stimulating lipolysis. They're working to get fat out of the fat tissue.
Sure.
So if you remove them, you can no longer get fat out of the fat tissue, and now it accumulates to excess. And this is, by the 1960s, was very well known, such that the leading authorities on fat metabolism were postulating that obesity was like body weight was a balance between the hormones working to put fat into fat tissue, which is primarily insulin, and then the hormones working to get it out and the central nervous system working to get it out. So if you have an inhibited nervous system influence, you're going to get too fat. If you've got too much hormones, insulin, you're going to get too fat. And then all this vanishes because the obesity community is thinking, we eat too much. Let's figure out why fat people eat so much and we'll solve it. And let's tell all these people who are burdened with obesity. One of the great quotes from the early 1930s was the guy saying obesity goes, fat tissue goes from being a storage depot to a burden.
Right. Yeah.
And
Yeah.
let's figure out how we could get these people who are burdened with obesity to starve themselves and be happy about it. And then when they fail, we could blame them for all kinds of psychological disorders.
Right. And all these unintended consequences of cutting out fat, thinking it's a calorie problem. And now the obesity epidemic is just rolling on. So Gary, I first became aware of you in 2002. You had a very famous article in the New York Times Magazine entitled, "What if it's all been a big fat lie?"
Right.
And it shocked a lot of people, put you on the map in the nutrition world. Now, you had already written very insightful books about the physics world, about what you call pathologic science, and you realize that physicists did not have a monopoly on pathologic science. So it's kind of interesting how your journey from physics to salt to fat to diet and nutrition is just amazing.
Well, so this is my first two books are about bad science. I stumbled into this, became obsessed with it, and so the first book, I'm living at CERN, the big physics laboratory outside of Geneva. Today we would have said I was embedded with the physicists. I was living in the hostel, spending essentially all my waking hours with these physicists while they thought they had discovered these new particles, and it turned out that they had screwed up and they hadn't. So I was there for the 10 months I spent with them, 9-10 months. We thought that I went there thinking they were going to confirm this new discovery, which is supposed to be the greatest thing in physics in 40 years. Instead, I watched them learn how they had screwed up. and then wrestle with how to deal with it, because nobody wants to acknowledge to the community that you just made a mistake. And then it turned out that a lot of the earlier work people had done had been wrong, and so it became a real learning experience in how hard it is to do science right and how easy it is to do it wrong. And it turns out that in the physics community, they're very aware of bad science. The term they use is pathological science, the science of things that aren't so, which came from a lecture given by a Nobel laureate chemist in 1957 or 53. And it's just in those fields, particularly the high energy physics was unique because until very recently, if you claimed the discovery, everybody else who could possibly see if you were right would try to find out if you were right. And so they would look to see if your discovery was real. And if they couldn't reproduce it, it was intensely embarrassing, and basically your career was essentially over. Nobody would take you seriously again. And the physicists, every mistake like this was sort of common knowledge in the field. It was the folklore of the field. You told stories about them. You made fun of these people. Even if they had Nobel Prizes for other work, you could still make fun of them for their mistakes. It was just, it was accepted that this is all too easy to do, and the goal is not to do it. And Richard Feynman, the famous Nobel laureate physicist, said the first principle of science is you must not fool yourself, and you're the easiest person to fool. So I ended up that became my obsession, how easy it is to be fooled. My second book was about cold fusion, which was the sort of great episode of bad science in the late 20th century, and the book was called Bad Science. My friends in the physics community, and by then I had quite a lot of them, they liked what I was doing. They thought if the whole world were made of physicists, those books would have sold really well. Unfortunately, there's only about 2,000 of them. So, anyway, they said if you think cold fusion was bad, you should look at this shit in public health. Is kind of how it was phrased. They just pointed me in that direction and said, check it out, and it was terrible. And from there,
it sold itself. So Gary, I want to talk a little bit about why it is and has been so difficult to do nutrition research and get some bloody answers after all this time. So let's just talk about a few points. Let me just bring up some few points. I have an outline here. First of all is designing a study. How do you do it right? And maybe we'll have time to get into the 4 studies that NUSI, a nutrition science initiative that you helped spearhead years ago, to talk about some of the methods in that. But just designing a study and is so difficult, isn't it? When it comes to nutrition.
If you think of, this is how I think of it now, experiments in science, which are clinical trials in nutrition, basically ask a question. They ask one question. So you can get the answer. So you can get the answer to one question every time you do an experiment. And that question is based on what exactly you're doing. So I'm going to do this to that or to them, and I'm going to learn this. Under these circumstances, that's all I'm going to learn. What happens when I do this to that or to them? In nutrition, what you want to find out, there are various aspects of what we want to learn, but generally we want to know what a healthy diet is. And a healthy diet is a diet that's going to keep us healthy longest, that's going to minimize chronic disease risk. If we have a chronic disease, a healthy diet might be the diet that puts that chronic disease into remission, if that can be done by diet. So if the question you want to ask is, if I eat diet A or diet B, which diet is going to make me live a longer, healthier life? But now we're asking a question that takes, and it's effect a lifetime to answer.
The duration is so long, it's
Yeah.
almost undoable.
It is almost on. You can get around it to some extent. Everything's a trade-off here. So, for instance, if I just want to know, like I could do an N of 1 with myself. Well, I can't, but let's say I have an identical twin. And I can go on diet A and he can go on diet B, and everything else about our life is the same. We might find out that he lives 10 years longer than I do, and that might be because of the diet, although it might not. If you use enough people, you could go for shorter time. Say you get 10,000 people and you're looking at heart disease risk and diabetes risk and cancer risk and Alzheimer's risk, all the major chronic diseases. Maybe with 10,000 people, 5,000 each group, for 10 years, you will see a difference in disease rates. Maybe you'll need 25,000 in each group, and then you could, but the problem is now you got 25,000 people you have to try and keep on these diets. So it's going to be very hard to convince each and every one of them in the way you might as a physician how to eat properly, how to eat diet A versus diet B. So you're going to get poorly controlled study. And it's even poorly controlled, it's going to take 10 years to do it, and say 5 years to set it up. And it's going to cost $100 million to $500 million because those studies are very expensive. And when you're done, one of the lessons from my other science writing and my books on bad science is when you're done, and my not-for-profit, is you might have only learned how you fucked up the experiment, if you'll pardon the non-technical terminology.
Right.
So now you've spent $500 million, 15 years of your life, and the government's life, and the answer you got is, this is how we should have done it to begin with.
So I hope our audience understands it's just frightfully difficult to do nutrition studies properly. Just inherent. Yeah. It's inherent in the subject.
And in other fields, the fields that work best, that are the most functional, are the ones where it's easiest to do the experiments. So somebody comes out with, like, I got the opportunity in my youth to interview all these physicists from sort of the golden era of physics research in the 50s, 60s, and 70s. And I had these guys say, look, we would read about this discovery in, the physics journal on Friday, and we'd get on the phone with each other and we'd go, we can do this experiment. We've got the parts in the lab, and they'd go in on Saturday, and they'd, some of the parts they'd have to get from the junk heap, and they'd throw this thing together, and these are really smart people, but by Monday, they'd have tested the hypothesis, they'd have a pretty good idea whether what they had read was right or not. The longer it takes, the more complicated it is, the more expensive it is, the more disconnect there is between claiming discoveries and finding out if they're true, and then the field starts, the hypothesis and test aspect of science tends to fall apart. And meanwhile, good scientists never want to come in second. So an absolutely fundamental aspect of the scientific method is reproducing other people's work, independent reproduction, a replication of an experiment. But if you do that and the guy was right, you don't get any credit for it.
Yeah, it's thankless. It's thankless.
So it's sort of... and if you find out that the guy was wrong, you might not even bother publishing the paper, unless the guy's getting a lot of publicity in the New York Times and Science Magazine and Nature, and then you go, we got to slap him down, so now you're going to publish the paper, but you won't be published in as good a journal in your article. It's really a messy, messy field, a messy, messy sort of endeavor, and nutrition is harder than anyone, but let me tell you where it's not that hard.
Please do.
Okay? Because I said, if you want to find out which diet is healthiest, you want to know who's going to live a longer and healthier life. But if you have a chronic disease, a disorder, and that disorder has a large dietary influence, now you could put people on the diet and see who gets better and who doesn't. And it might take only a few dozen people and a few months to see
In a
an
few months.
effect. And you
Right.
could do it with yourself without needing you need the randomized controlled trial to tell you if diet A is better than diet B, and you need the randomized controlled trial to tell you if diet A or diet B or some control have long-term consequences that you'd like to avoid.
Right. Separate question, however.
Separate
Right. Because
question.
you want to know if you're going to feel better soon.
If you want to know if you're going to feel better soon, like if you're overweight and or obese and you want to know is this diet going to make it easy to lose weight,
Right.
all you have to do is try it.
Right.
So things get very easy when the goal is to see if you can put I'm very easy as an exaggeration. They get relatively very easy if that's your goal.
Yeah. Sure.
As soon as you want to just establish the healthiest diet for everyone, then you're stuck in this world of impossible to do impossibly expensive clinical trials.
Yeah. Now, in 2005, Gary, I was living in D.C., and I figured, I was president of the Carbohydrate Awareness Council, and I was going to go to the dietary guidelines open comment section. You have 3 minutes to speak in front of the dietary guidelines board and make your case for something. Out in the audience, it felt like a circus. There was the vegan people and the PETA people. I mean, I'm not putting them down. I'm just saying there's every different worldview out there, okay? Short of clowns and juggling, it was all out there, and everybody came up and made their pseudoscientific presentation, but they all had hidden agendas. Hidden agendas that people don't, they come across as being scientific, and this goes all the way to the top of our scientific researchers and department chairs and whatnot. They might have a very strong personal or religious or ethical bias towards something that doesn't even come out. Have you seen that?
Again, this is this is a problem we face everywhere in the world now.
Sure.
The internet has democratized information. Everyone
Yeah.
gets a voice. From the wisest people in the world down to, nutcases and pathological liars. And then they're very hard to tell who's who. And then once you start paying attention to something, the algorithms, Facebook algorithm, the Twitter algorithms will just flood your life with people who think exactly like they do. So we all get siloed into various belief systems. And in science, it's worse, particularly nutrition now and obesity research, the field I know best, because you've got so many people doing research. It's an academic research industry funded by the NIH. So you're a professor in medical school, you've got 7 graduate students, each one of them has to get a PhD, so you have to do 7 different studies so you can generate theses for these people, and you're going to get funding from the NIH, which might be $500,000 a year for 5 years for your laboratory. And so everyone does these tiny little kind of meaningless studies. And then they have to make them seem important because they have to get them into journals. So then you kind of spin them to make them look important. You can't say, well, I just did this tiny little study and I don't know whether to believe it or not because I'm a good scientist. Instead you say,
there's real world requirements.
Yeah. So, and then you've got quite literally hundreds of these articles coming out every week. And so you've got the social media where everybody's siloed into their belief systems, and you've got them picking from these hundreds of articles every week whatever it is that they believe that supports their perspective. And of course we're one of those silos, and we're people doing the same thing. I'm not, we're all doing it.
Yeah.
In theory, some of us are right and the rest of us are wrong, but how can you tell?
Right.
I mean, I was just reading today a guy who was he was commenting on this keto CTA study, and it's like it now proves that keto is deadly. And he had a lot of followers on X, and about 700 people had come, 70 or 700, I forget, a lot of comments on this thing. And I was going through them because I was feeling masochistic, I guess.
Right.
And, I mean, it was crazy. Everybody, all these people speaking with certainty about things that they knew nothing about. And making statements, doctors, bodybuilders, personal trainers, dietitians, making statements about research they'd never read. That I'm willing to bet that they had never read the primary sources.
Mm-hmm.
And it was all, but if you were just reading this guy's, if you were following him, it was pretty convincing. Yeah. And, one of the messages I've tried to get across, particularly in my latest books, again, is this idea is that you can experiment. We all get to keto eventually, those of us who do, because for the most part, nothing else works. Okay? Because Lord knows if something else worked that didn't require never eating pasta, again, I'd have stopped there.
Right.
That's simple.
Right.
It was a pasta. So you end up getting to us because nothing else works for you. And then you have a world of people saying, but it's going to kill you, or of course it fails, or this is crazy. Anything will work if you do it right. And you want to say to them, but I was a pretty smart, dedicated guy who knew how to do things right, who paid attention. I did a lot of things right, exactly the way I should. And the only thing that worked was keto.
Right.
Back to Atkins when we got into this business. So that's why I still do Atkins, because I was reading one paper where the researchers were talking about where were they from? I forget. Wasn't they had selected out? Oh, the Mayo Clinic, I think. All the patients who had come to the Mayo with like high LDL cholesterol, they had lipid disorders, and then they went through their records to find 17 who had been on ketogenic diets, and those were the patients they specialized on. They demonstrated that these patients, their LDL went up on keto. When they went off the keto, the LDL went down, and I wanted to say to them, but what about their weight when they went off the keto?
Right. They're looking at selected endpoints, and it's
if you're only picking LDL cholesterol, we get it. A lot of us LDL cholesterol goes up when we eat keto, but what about everything else that are great? Obesity is a far greater risk factor for heart disease and high LDL, and diabetes is a far greater risk factor, and hypertension.
I think Ken Berry has some wonderful slides where it shows the increased risk due to like LDL or something. It's percentages, maybe 15%. And then you look at triglycerides, which it's like 10-fold, 12-fold increase. So the magnitudes of difference are just amazingly disparate. I mean, they don't even fall in the same ballpark. Now, Gary, I would like to learn some things about your work over the years, and something I don't know enough about is that you started a nutrition science project called NUSI back in, I'm not
2011, 2012.
2011. Now, did you co-found that with Peter Attia?
Peter and I co-founded it together, and
maybe I jump in. We've already mentioned, I set this up because we've already talked about that study design. To do these studies properly takes a lot of money. And I was so proud of you for finding some rich guy or some rich guys to actually get the money to do some of these very important studies. Is that accurate?
I mean, they came to us, so we just had to say yes.
They came to you.
It was so the idea, so again, remember, the experiments ask particular questions. If we want to know which diet is healthiest for everyone, that's a lifetime. That takes decades. But there are questions about, when I'm talking about these competing hypotheses of obesity. Do we get
Yeah.
fat because we eat too much, or do we get fat because the carbohydrate content of our diet drives up insulin, which makes us store excess fat? That's the gist of it. So the question is,
Right.
can those competing hypotheses be tested? And now you're asking, can I design an experiment where they each make a prediction, and only one prediction is likely to be right? So, if you believe that obesity is caused by eating too much, and I feed you, I figure out how many calories you need to get about your normal life today, like,
Right.
I could give you something called doubly labeled water, for instance, and over the next 2 weeks, it'll tell me about how much energy you expended every day. So, and if I know how much energy you expended, and I know that your weight's stable, I know how much you're eating every day, because energy in is equal to energy out, if you're not gaining or losing weight. So you could basically say, let's assume you burn 2,500 calories a day. So I'm going to feed you 2,500 calories a day of a high carb diet, high in sugar, and see what happens to your weight. And then I'm going to let you go back to baseline. I'm going to feed you 2,500 calories a day of a ketogenic diet, which minimizes insulin levels.
Right.
And I believe that if you minimize insulin levels, you're going to lose weight, because insulin not only does it tell your fat tissue to take up fat and store it, it inhibits your fat tissue from letting the fat go. So
I'm going to back up a second. So you were able to get the funding, make the protocol, and actually do a pilot study doing this. Am I right?
Well, we actually had funded 2 of them. And of course, they didn't get different answers, but they were interpreted as getting different answers. Yeah,
Okay.
so I had this idea of one experiment that could be done to test these hypotheses. Peter looked me up because he liked what I was saying about diet and thought my books were intelligent. I was impressed with him. Clearly a very, very smart, talented guy. We thought about starting for the not-for-profit. I get an email one day from a guy named John Arnold, who said he had heard me on a podcast. And I was talking about obesity, and I was talking about these studies, and he had a foundation that was trying to do, a charitable foundation that was trying to change the world. And here was an idea he thought, thinking like a sort of venture capitalist, that he could make a small investment, and if it panned out, it would change the world. So I Googled John Arnold, realized he was worth at the time like $4 billion. He was 37 years old. I sent the email to Peter.
Got your attention there. I hear you.
And Peter went to Houston and met with them, won them over, and they agreed to fund this not-for-profit.
So that's how it happened. It was serendipity. The stars aligned. You've met the billionaire.
Actually, there was even more serendipity than that. This was, like I said, around late 2011. They had just hired a new science director for their foundation. And this was a guy who actually had a PhD in education from Harvard and, if I remember correctly, a law degree. And he had read Good Calories, Bad Calories in 2007. And he actually had reached out to me then because he had found it so interesting, and we had gone back on email about how this could be tested and what had to be done. And now, out of nowhere, I don't even think he had started yet at the Arnold Foundation when Peter had gone to meet with them. But once he started, it was like, yeah, I'm all in, this guy. So we worked together. We sort of came up with the idea of the experiments that had to be done. We recruited the people we thought should do these experiments. I had interviewed essentially anybody who had done anything in obesity going back to the 1960s, and I had a very good idea of who was open-minded, who was a good scientist, and who wasn't. By the way, I was wrong.
Yeah, there's a guy in San Francisco. Yeah, I'm going to name some names in a second. I may be. But
Well,
anyway,
actually, I mean, even on a more profound level, it was a real learning experience in again how hard it is to do science right. I used to describe it
yeah.
as like Peter and I were like the Hardy Boys started not for profit, and
Uh,
we had no idea kind of we were making, nobody had ever done anything like this before, so we're making it up as we go along, trying to figure out how to do this, who to do it, what has to be done, while simultaneously being treated like some of these people as we should stay as far away as possible because we have a belief that they thought biased us, as though we were the tobacco industry hiring them to do tobacco research that we could then get them to, publish and claim that tobacco is harmless or it's not addictive or something. I mean, that's literally how a few of these people perceived us, not all of them. And so we ended up funding 2 studies that could test this energy balance versus carbohydrate insulin model.
Now, was that the Energy Balance Consortium pilot study? Was that one of them?
That was one of them. So that was Rockefeller University up in New York. Is it Rockefeller?
Right.
Yeah. No, Columbia, not Rockefeller. NIH, this research operation in Florida, the name of which I forget, and then the Pennington Biomedical Research Center in Louisiana.
Was the other one the Framingham State Food Study or the Diet Fits?
No, the other
Gardner.
was Framingham. Diet Fits didn't test this hypothesis. I actually wouldn't have funded Diet Fits if I had my druthers, but I hadn't.
That was an olive branch. It was an olive branch to the A to Z guy.
It was an olive branch to Peter. But who was giving an olive branch to the Stanford guy.
The Stanford guy, exactly.
Yeah.
The Stanford guy who showed that the low-carb diet kicked ass and then pretended it went off and it disappeared. It was such a...
Well, on some level, they all did. That was a weird thing. I mean, even the pilot study actually showed that if you fix calories...
Yeah.
Low carb increase, it gets complicated because the investigators didn't think, if you fix the calories in the 2 diets, so you go from a high carb diet to a ketogenic diet, but you keep the calories the same, and if you believe in this energy balance thing, overeating and undereating causing obesity, then you should see no change in weight. That's what they believed, and they didn't think they'd see a change in weight, but they figured we could measure energy expenditure of these people and these devices called calorimeters. That made the experiment significantly more expensive, but you hire these people because they know how to do experiments, not because we knew what we thought they should see, but they were the ones who had to design the experiment. So anyway, you're looking at how much energy is expended by these people on the different diets. And if energy expenditure goes up but calories stay the same, then it means weight has gone down even if you can't measure it. And both the Harvard study, which was run out of, I think it was probably Framingham, and this consortium of these 4 groups both saw more energy expenditure on the ketogenic diet, which could not be explained by this energy balance hypothesis. But the Harvard professor, David Ludwig, he said, we've seen more energy expended. He believes this carbohydrate insulin model, so he interpreted it as support for the carbohydrate insulin model. This consortium group, which saw the same thing but a smaller effect, said, well, we expected to see a bigger effect. And because we only saw a small effect, this doesn't support the carbohydrate insulin model. And we were saying, but it can't be explained by your model. It can't.
Yeah, they spun it. And I think they also complained that you didn't randomly start one in front of the other. They said there was.
Well, we complained about that. I mean, there were, it was called a pilot study for a reason.
Right.
I mean, this is really inside baseball, but
This is what I want to hear. This is why I've got you on here, Gary. I want you to give me the backstory so I can understand the results and why they weren't, or they were spun a certain way.
you know, in order to, you never know when you do these experiments. I guess I should bring this up in my next Substack post. Because it was the same problem. You do one experiment, you do one diet, then the other, and then you never know if what you've changed in the first period is affecting what you're doing in the second period.
Yeah.
So the way you solve that in clinical trials is you either use entirely different people. If you've got your 10,000 people, you put 5,000 on one diet and 5,000 on the other. But if you've only got 20 people and you want to, sort of maximize the possibility you'll see something interesting, you randomize them to which diet comes first.
Right.
But now you have to separate the diets in time, because you imagine if you went from a very low carb diet to a low fat diet, you might have an entirely different effect than if you went from a low fat diet to a very low carb diet. Sure. You don't know. I mean, you would. We do know. It would be an entirely different phenomenon. But so you have to separate them in time and let them wash out the effects of the diet. So you put them on the low carb diet for 4 weeks, then you spend, say, 4 weeks letting them eat what they always ate, and then you put them on the low fat diet. So you're pretty confident that when they go from their control diet to their low carb diet, they're also going from the control diet to the low fat diet. None of that was done. No randomization, no washout, because it was expensive and we wanted to get a feel for what they might see. You don't want to have to lock these people in a metabolic ward for 3 months or 4 months if you could do it for 2 months and kind of get a feel for what the next experiment should be. But by the time this experiment was done, for whatever reason, one of the principal investigators, this guy Kevin Hall from NIH, decided that they had learned enough. So even though the trial wasn't randomized, even though there was no washout period between the diets, even though they didn't do this and they didn't do that, all kinds of measurements that they had to do a good experiment, Kevin decided, we've done enough. We know that there should have been a bigger effect. We didn't see it. This refutes the carbohydrate insulin model.
Yeah,
the guy at Harvard was saying, Ludwig, who did a randomized trial, was saying our results confirm the carbohydrate insulin model. Complicated.
So how does this Kevin Hall guy get off saying, quote, that the hypothesis, this insulin carbohydrate hypothesis, was falsified by experiment? He's just poo-pooing the whole thing, threw it out in such a biased way. I mean, it just gets me angry.
You try not to get angry, although I spent a lot of nights at 3 a.m. muttering effing Kevin Hall to myself. It's a difficult problem. So when you think about it, so you've got a community of scientists, sort of scientists, who all believe one thing. They all grew up believing that obesity is caused by eating too much. That's what their friends believe, their colleagues believe, the people across the hall believe. It's like the church of calories.
Right, it's the
and
church
they all
of
belong
calories.
to the church of calories. And now a few people come along, a journalist, a guy with a PhD in a field called behavioral psychology, this Harvard doctor who's kind of annoying, and they're all kind of annoying.
And a general surgeon from Johns Hopkins.
Yeah, and they're all saying...
Who the hell is he?
They're all saying, you guys are all wrong. You're all wrong. You're completely wrong. So it's exceedingly easy to find us annoying. It's very hard not to be annoying when the subtext of what you're saying is, you guys are all wrong. Every last one of you, everything you're doing, wrong, wrong.
So annoying, because now you have funding.
And now we have money. So
Yeah.
now they do an experiment that suggests that we're wrong. It's very easy to just say, you guys, you go away. We're done with you. We spent 5 years of our lives. It looks enough like you were wrong that we're going to claim you were. Because the odds that you were right are so tiny. You know, for everyone who says, you know, the world is, I used to, when I worked for the science magazine Discover in the 80s, I would write these articles about theoretical physics and the search for the theory of everything. And every time I wrote them, I would get a few letters written in crayon from people explaining to me what the theory of everything really was and how they had figured it out. And I learned as I was doing this that the people who wrote in crayons were in prison because they weren't allowed to use sharp pencils or pens. And they were explaining to me how all these physicists were wrong. And they had discovered the real theory. And I, of course, wouldn't read the letters because, like, you know, life is short. What are the chances that these people are really right? It's infinitesimal. It's not worth taking seriously. Had they come to me with $20 million to test their theory of everything, and they were getting publicity the way I was getting publicity for these ideas in these books, I might have said, okay, let's do it. But as soon as I have this glimmer that you're as wrong as I know you must be,
the bias,
I'm going to jump on it.
Right.
And because 99.99% of the community believes that we're wrong, if you publish a paper saying we're wrong, you win a lot more friends.
Oh, yeah.
Than if you publish a paper saying, you know, there's something to this argument they're making. So again, I'm sure from Kevin's perspective, he believes and still does without a shadow of a doubt that his analysis was correct, his assessment is correct, that I'm just biased and I can't see the reality of what they had done. And, you know, I would get these arguments, people on Twitter, X, often bodybuilders for some reason, like convinced, because when they want to become cut before a competition, they'll often cut out all the fat they eat. So they know that fat causes obesity, because if they have to lose 2.5 pounds of subcutaneous fat, they can do it by... Anyway, they'll...
Well, that's the minority, by the way. Bodybuilders have always traditionally cut before a show by eating meat, fat, and water. I mean, that's been the way to cut for decades. So
no, that's part of it. Apparently, if you really want to cut, then you can also cut the fat off the meat. It's just they'll say, you know, you've been proven wrong, and you can't accept you've been proven wrong. And I say, well, how do you know that we've been proven wrong? And then they'll say, well, here's the Kevin Hall pilot study, although they won't call it a pilot study. And I'll say, well, what about the Ludwig study? They'll say, you funded an experiment that proved you wrong. I'll say, but first of all, it didn't prove us wrong. We funded an experiment that generated evidence that was interpreted as falsifying the model. I would even disagree with the interpretation. But we also funded an experiment that generated evidence that was interpreted as supporting the carbohydrate model and falsifying the energy balance model.
Right.
Why pick one?
Right. So Gary, I want to flesh out NUSI a little bit longer, and I want our audience to know that it was a labor of love that you and Peter put together to do NUSI. You did 4 studies, and before NUSI dissolved, I want you to tell me how NUSI dissolved. There were 4 studies. There was a pediatric study looking at non-alcoholic fatty liver disease, and I'll just tell our audience, it's when you get a fatty liver from eating too much sugar, primarily fructose, but carbohydrates, cause the liver to fill up with fat. And I think you showed in that study that the decrease in sugar improved the fatty liver independent of weight loss. Is that fair?
More or less, yes. Again,
Okay.
that wasn't us who showed it. That was the researchers at Emory University and the University of California, San Diego. And it was the least expensive study we did. It was 40 kids with non-alcoholic fatty liver disease, and they were randomized into two groups, and half of the kids got this diet, very low sugar diet. Foods were made for them. They were made, the large Hispanic population, because those kids are particularly high risk of this disorder, and the foods were given to them without any added sugars, and enough food so that the whole family could be fed, and there would be 20% extra food every week if they didn't, best we could tell. Anyway, in that study, very definitive, it was a, I forget if it was a 4 or 8 week study. It was another pilot study. We just wanted to know if you could see a change in liver fat over the course of 4 weeks. And you did, undeniably. These kids got better.
Yeah, it's
sort of,
yeah.
Its study has had precious little influence, because what it shows is, take the sugar out of the diet, this scourge of America's children, non-alcoholic fatty liver disease, goes away.
Right. And I can't tell you how many doctors still put people on a low-fat diet for fatty liver. I see it all the time. I see women with fatty liver all the time, and they're put on low-fat diets. It drives me crazy. One other study that NUSI did was a Framingham State food study.
Well, that was a Harvard study. David Ludwig study.
That was the Ludwig study. Okay.
Yeah.
And that supports the theory, the alternative hypothesis that hormones regulate fat accumulation. All right. And the last one, and then I talked about the Energy Balance Consortium, and then there was a study you did with this Gardner guy at Stanford, I think, who did this A to Z study in the past. And you once again, you had two groups, but you told both groups, you told people in both groups to cut out sugar and refined flour.
Well, he did. He
did. Yeah. So listen, when I learned experimental study, that once again for our audience, the goal is to make the groups as different as possible to get a strong signal, right? If you've got two groups on top of each other, you can't show a difference. But if you can get them far apart, you can prove your point. But by bringing them together in the beginning, you've by definition decreased your signal and your.
And again, it's like, this was part of the learning experience. And if you ask Christopher, and Christopher apparently was just on the Huberman lab talking about this.
Gardner, is that Chris Gardner?
Yeah, Christopher. He never goes by Chris. Peter
Sorry.
kept having to correct me on that too, because you want to call him Chris like you know him. Christopher.
Right.
The idea was, because again, if you do what's called a free living trial, so you have people living their lives, they're going to work, they're living at home, but you're going to teach them how best to eat. You're going to teach them, you guys eat this diet, you guys eat that diet. And we're going to give you counseling, and we're going to give you, every week you're going to hear from us for 2 hours how to eat. We're going to teach you how to cook. And then we're going to set you off, and you're going to eat the low-fat diet, you're going to eat the low-carb diet. And we thought the good thing about this study is you get the greatest differentiation between these two diets. Because in the past, when people had tried to put people on Atkins and they looked how much carbs they were eating, they were still getting like 25-30% of their calories from carbs. This is in Atkins. And right. Atkins, the benefit of Atkins, if it's not just eating less, is it minimizes carbs, so it minimizes insulin. So you wanted one group that ate the lowest carb diet you could get them on. Ideally, it would be around 10%. We didn't expect to get lower than that. The other group, it's going to be a low-fat diet and the lowest fat. But Christopher thought it was unethical to feed people in either group foods that he thought were unhealthy. And the foods that he thought, he's a mostly plant guy. He himself is mostly might be an ovo-vegetarian. I know he has chickens and eats eggs. But he also thinks sugar's unhealthy and white flour is unhealthy and white rice is unhealthy. And so even the low-fat group, he told, don't eat sugar, don't eat white flour, don't eat white bread, don't eat, So what you're doing, they're carbohydrates, right? So you've got one group where you're restricting carbs and one group where you're supposed to be restricting fat, but now you're restricting fat and carbs. And you're restricting the term I hate, but I'm going to use it, the most obesogenic carbs, if this carbohydrate insulin model is correct.
Right, I like it. White bread falls in that category.
Yeah, so basically you're telling both groups don't eat sugar and white bread, but you're going to restrict fat also, and you're not.
And the real world is nothing. So anyway,
and then, then it gets worse. It gets worse, because then he decides he doesn't want people to drop out of the trial because they're looking at like a year of not eating any of their favorite foods. So after 3 months, he tells him you could start adding carbohydrates back to the low-carb diet. And I think he might have told him you could add low-fat back. But now he's making the diets even more similar.
Yeah, so you've proven nothing. Yeah.
And nonetheless, well, when it's done, they end up both losing weight. Both groups lose weight. But when we funded this study, as I said, I'm going to blame all this on Peter.
Okay.
I knew
He's
we
a
had
big
met
boy.
with,
He can take it.
I knew we had met with Christopher. I had no idea, because this study doesn't actually test the carbohydrate insulin model versus the energy balance model, because to do that you have to fix exactly how many calories your subjects eat, or you have to be able to measure exactly how many calories your subjects eat, and you can't do that if they're living. You can only do that if you have them confined in a ward somewhere.
Right.
So this was not a study I wanted to fund, and we ended up doing it, and by this time we had this, not-for-profit. It's running out of San Diego. We had a public relations woman who had hired a videographer to do a documentary with these people. So
now you're big time.
Yeah, when we got these amazing results that we were going to get, paradigm shifting, we would be able to do a documentary on it. So I'm looking at the interviews that this guy had done with some of the subjects, participants in Christopher's Stanford experiment. And they're talking about not eating sugar or white flour. And I'm like, wait a minute, this is now 3 years into the funding. He's telling the low-fat group not to eat sugar and flour. He's carb restricting the low-fat. He's never going to see an effect. And then when it comes out, he's going to publish a paper saying low-carb versus low-fat, no difference.
Right.
When he's removed the sugar and flour from the low-fat group, and that's probably the biggest problem. Anyway, it was an interesting learning experience.
Yeah. So Gary, you tried, you got funding, you did 4 studies, and then what was the retirement of the NUSI project? Give me a little insight. How did NUSI fade away?
Was getting frustrated, and he had only planned to do this for 5 years. Okay. So as we were coming on the 5 years, he was getting antsy. We were not raising money. The Arnolds, who were funding us, always thought that it would be easy for us to raise money for more studies from their billionaire friends, that they had put us in touch with the Gates and with Warren Buffett and billionaires in New York.
Gates is biased against meat. He wants us to be vegan, so there's a bias, right? He's not going to help you.
Well, he didn't. But again, it wasn't about meat. It just turned out to be Peter had the job. I wanted nothing to do with this. Peter, part of his job running the organization was going around the country, meeting with these billionaires and their experts and trying to convince them this was important enough. Figuring out the ultimate cause of obesity. Do we have the right paradigm that they should fund research to support it? And they didn't want to fund that kind of research. They thought, well, if I get cancer someday, or my, kid has this disorder, I want to fund research on that disorder or cancer or something where I could turn it into a discovery that we could invest our money in, and we could make money off it, because these people want to make money. They weren't interested in funding this kind of science. So Peter was getting frustrated. He had planned to leave anyway. The Arnolds were frustrated with us and our management of the organization, and they had it out with Peter. He was the president after all, so he resigned. We tried to fill his shoes with first one guy who may have been wonderful what he did, but was a disaster for us, and then the woman we promoted up, who was our sort of directing our technical operations, who was very good, but it wasn't working, and the Arnolds knew it wasn't working. And there was one more experiment we wanted to, basically the Kevin Hall experiment was a pilot study. So we learned what we shouldn't do in that study, and now we wanted to fund a randomized controlled trial that would cost $20 or $30 million with the other. Kevin had stepped away by then. He didn't want anything to do with us, and it was mutual. And we weren't sad to see him go. And the other group had, the other three centers put in a proposal for a study they wanted to do. And NUSI, at this point, we had finished the other studies. Our only reason for existing was to oversee that proposal if the Arnolds funded it. And we thought this group of very well-respected academics had basically filled that proposal with a lot of pork barrel crap, that they wanted to get funded for their colleagues that had no real meaning. So we told the Arnolds this, and we pointed it out, and we said, look, we don't have to fund this. We don't have to, this, they're asking for 30 million. It should be like 15 or 20, and we can get rid of this, we can get rid of that, we can get rid of that, because it's all meaningless. It's just supporting their buddies at academia. And the Arnolds kind of agreed with us, and we thought they would fund the study minus the things we had pointed out. And instead they said, look, you guys are a bad marriage. Clearly. So even if we want to fund this study, having it managed by NUSI minus Peter Attia is not a good idea, because you've proven that you're a bad marriage. And nobody should go into a bad marriage hoping that if you have kids, it'll get better. That was the metaphor they used. So they decided, you guys get divorced. Once they were divorced, NUSI has no longer any reason for existing. So we immediately started winding ourselves down, and then the Arnolds put out a request for proposals separately, and they said, we'll manage it, and you guys can consult with us, so we'll still get your input. And people put in, I don't know, they maybe got 20 applications for this request, one of them from the collaboration minus Kevin Hall, one from David Ludwig's group at Harvard. They ended up funding Ludwig's group at Harvard to do a study for like $20 million. And that study basically died in COVID. Not basically, that study got up and running and died in COVID. And during the shutdowns, as many research projects did. So that was pretty much the end of it. I don't know what.
Okay, that's what happened in NUSI. So looking towards the future, because I want to start wrapping this up, Gary, because one of my goals of this discussion with you is to kind of say, what did we learn? What do we still have to learn? And where might this be going in the future, so that we can get some bloody answers to this question? Is it this calories in, calories out, or do we have a hormonal module of a model for obesity?
Well, and it's interesting, because that's where we stand right now with the MAHA movement in the federal government, right? So you've got RFK Jr. Running Health and Human Services. You've got these new people, Jay Bhattacharya at NIH and Marty Makary at FDA, and their world is basically our world. It's kind of the irony that, I mean, I have many issues with RFK Jr., and in an ideal world, I would not, if I were king of the universe, he wouldn't be running Health and Human Services, but he's put people in place.
Casey Means is in line for Surgeon General or something.
Casey Means for Surgeon General, but they're all basically, like Jay Bhattacharya and Marty Makary both endorsed my last book for me. Marty was Peter Attia's mentor when Peter was a surgical resident at Hopkins, and I met Marty through Peter. He was always a supporter of what we were doing. So there's this belief that you have to redo the dietary guidelines, but the problem is you want it to be evidence-based. So you want to be able to say these people should kind of eat this, and those people, this is a healthy diet for them. But now we get into the exact same problems that I described when we started about the kinds of experiments, clinical trials that have to be done to give us confidence to tell people you should eat low carb, you should eat low fat. There's ways to deal with it in writing the guidelines where you say this is what we think we know, and you don't say it's definitive. But if you think about it, for instance, a few weeks ago, RFK Jr. was in the news because he had said sugar is poison. And I've written a book called The Case Against Sugar. And I would have been delighted if he said sugar may be poison.
Maybe, right.
Because as soon as he says sugar may be poison, you could choose to avoid it if you want to, because it may be poison, and most of us avoid things that may be poison. But you also know, well, let's find out if it is or not, right? Isn't this important?
Right.
So if it's important, then immediately you can start designing studies to find out if is sugar indeed poison or is it just empty calories, which is the conventional wisdom.
And I was talking to the Eads a few days ago, and the Yudkin statement came up in 1972. He called sugar, the name of his book was Pure, White, and Deadly.
Yeah.
So that's what I said. That's 50 years ago.
There's nothing. I mean, this was the idea that but again, we also have, we have these people who are now saying seed oils are poison. And they're saying seed oils are more poison than sugar. They're implying that if we got seed oils out of the diet, we could all eat ice cream sundaes as long as the ice cream is made from cream and not soybean oil. So there's all kinds of belief systems out there.
Still not evidence-based.
Or there's some evidence, but certainly not enough evidence to convince people who think otherwise, which is the goal of science, is to create evidence that you can't, talk yourself around, in effect.
Right.
So what I'm hoping is this new government, Bhattacharya, Makary, Casey Means, that they'll say, okay, this is what we think is true, and we're going to set up this organization to figure out how to get the studies done that we need to get done, so once and for all we could stop arguing about it.
Wouldn't that be nice? And it will take time. There will be all these problems that you discovered in NUSI, in the real world, doing real-world studies with real-world interpretations, real-world problems.
It's a problem. It's going to be, but again, in the meanwhile, what can you tell your patients? Like, hey, my patients do very well on ketogenic diets.
Yep.
Their blood pressure comes down, their blood sugar gets under control, their weight comes down. They experience better health, and it happens quickly enough that, try it for 2 or 3 months. Just do it right. Don't cheat. Give yourself a chance. Give it a chance to succeed for you and see how you feel. At the end of 3 months, if you don't feel better, you can go back to eating the crap you're eating now.
Yeah.
No.
And my fertility patients, they stop, not all, but they have fewer miscarriages, they have fewer problems in pregnancy. I mean, so my patient is very tangible because it's very close to something they're dreaming about. They're very motivated. So I treat a subset of people.
I know we're running long, but I want to tell you one story from my diabetes book.
I would love to hear a story to wrap this up, Gary.
So, back around 1970, this guy, Richard Bernstein, the Atkins of the diabetes world, he's got type 1 diabetes. He
just died. He just died.
Passed away at 90, yeah.
Right. 92 or something, yeah.
At that time, I think he'd been diagnosed. He'd had it for 24 years. His life expectancy was probably not another 10 years. He had all kinds. So he figures out a way to measure his blood sugar, and he becomes the very first person to ever measure his blood sugar at home, the very first, multiple times a day. And he realizes that he starts doing an experiment because he's got an engineering degree. So, measure it in the morning, measure it after breakfast, measure it before exercise, after everything he eats, and you could change. And he realizes that he's got type 1 diabetes, but he can't keep his blood sugar under control if he eats like bread. Just can't do it. There's no way to dose the insulin to control for the bread. So he ends up with this very low carb diet that allows him to use very low doses of insulin. So if insulin's got any negative consequences, not a problem because he's minimizing the dose of that. He calls it the law of small numbers. And Bernstein's into networking. So he joins the Juvenile Diabetes Foundation which is brand new at the time, and he gets on the awards committee. This is outside in Westchester County, outside of New York, so he could meet the people they're giving the awards to, or major diabetes people in the New York area, which was a hotbed of diabetes research. And he says to these guys, I can keep my blood sugar normal. I'm a 24-year, now it's like 30, I've had type 1 diabetes for 30 years. I can keep normal blood sugar. And they say, that's impossible. He said, let me show you. So he proves it to them, and they're fascinated, and they want to do experiments. And back then, the kinds of patients who were really motivated to keep their blood sugar under control were women with type 1 diabetes who were pregnant. They had, even back then, terrible outcomes, very high risk of mortality for both them and the child, the fetus, and very high risk of birth defects and preeclampsia. And often they would have to be, live in the hospital for the last trimester of the pregnancy. So if they had hope that they could avoid this, they would do anything.
Motivated.
So this group at Rockefeller, pretty sure it was Rockefeller or Columbia, I'm always getting mixed up. It's been a few years since I wrote the book, decides that they're going to use pregnant women and they're going to randomize them into one group gets Bernstein's protocol and the blood sugar monitors, and the other group gets, what they always do for women with type 1 diabetes. But the women in the group don't want to be randomized to the control.
They all know. They've been talking.
They just want to do everything they can to make sure they have a healthy baby. And they get to be a mother to the baby for the rest of their lives. For a long life, not just like 2 years or whatever, 10 years. It was terrible. So they end up they put all the women on Bernstein's protocol, and they compare them to healthy pregnant women. And they do better.
They do better than the control group.
Than the healthy control group. I mean, it's unbelievable. And they still can't convince the diabetes community that they should tell their patients who are struggling with this awful disease that they should just restrict the carbs they're eating, because all disease is about, it's all the symptoms are a response to the carbohydrate content of the diet. So don't eat them. That's the thing. You don't have to eat them. Nobody putting a gun to your head and saying, eat pasta.
Yeah, I'm fond of saying there is no dietary requirement for carbohydrate.
There is
zero.
No dietary requirement. Anyway.
Zero. Anyway, that's a great anecdote, Gary. And honoring Dick Bernstein, who did just pass, a
We
great
did just
man.
pass.
And I did get to meet him in the early days in Brooklyn, early conferences where we met. So, Gary, what a pleasure it is to see you. You're looking great. You're still sharp as can be. I'm so glad to hear you're working on another book. All your books are fantastic. I would encourage everyone to go to your website, Gary Taubes. Your books are there. Your bio is there. Your books, Rethinking Diabetes, The Case for Keto, Why We Get Fat.
Case
Classic
Against
book.
Sugar.
Case Against Sugar. Thank you very much.
Good
Is there
tell.
anything else you'd like to shout
Yeah,
out, Gary?
I'm writing this newsletter on Substack now. Uncertainty Principles, because it's as much about good science and bad science as it is nutrition. And yeah, there we go. Subscribe to Uncertainty Principles. You could Google me, I hate to self-promote, but
It's the way it is, Gary. It's the way it is. It's the new game. It's the way you play it.
yeah. Gil, it's been
Fantastic.
great.
What a pleasure talking to you, Gary. All the best, my friend, and we'll see you soon.
See you soon.